Alright, this is practice problem 1.8. So calculate the density of mercury if 1.00 times 10 to the second grams occupies a volume of 7.36 centimeters cubed. So the first thing we want to know is that if we remember the density equation, we know that density is equal to mass divided by volume, right? We have the mass, which is 1 times 10 to the second grams. So 1.00 times 10 to the second grams, right? And we can divide that by the volume, which is given to us in 7.36 centimeters cubed. Right? And so we actually have the right units because we have grams and centimeters cubed, which we can express density as grams per centimeter cubed or grams per milliliter. And we find that this comes out to 13.6 grams per centimeter cubed. Okay, the second part of this question is calculate the volume of 65.0 grams of liquid methanol if its density is 0.791 grams per milliliter. So here we're looking for volume. Right. We have the mass, which is equal to 65 grams. And we're given the density, which is 0.791 grams per milliliter, right? So if we use the density equals mass over volume equation and solve for volume, we get volume is equal to mass divided by density. Right? So once again, we can take 65.0 grams, divide that by the density, which is 0.791 grams per milliliter, and what we get is 82.2 milliliters. Okay, and so we have three significant figures because basically we have three significant figures for the mass shown here, and we have three significant figures shown for the density, least number of significant figures. The third part of this problem is what is the mass in grams? So we're looking for mass of a cube of gold. It has a density which is equal to 19.32 grams per centimeter cubed. Right? If the length of the cube is 2.00 centimeters, okay, so length is equal to 2.00 centimeters, right? And we know that the volume of a cube is equal to the length cubed, okay? And so if we solve the density equals mass over volume equation for mass, we get mass is equal to density times volume. We know the density is 19.32, right, grams per centimeter cubed. We can multiply that by the volume, which is going to be 2.00 centimeters, and this is going to be cubed, right? So we're cubing both the 2.00 and the units, so centimeters. And so if we solve for this, we basically find that the mass is 155 grams. Okay, so basically we can see from the volume shown here that we have three significant figures, the 2, the 0, and the 0, whereas for the density we have four significant figures. When we multiply, we take the least number of significant figures, so 3, so 155 grams.